welcome back to another video on our falling object game. In this video we're going to be creating the object that is falling from the top of the screen to the bottom and getting all of that working. So if we go into our project and actually if we go and look at our little project overview document here, we're going to work on our falling object. We want the object to move from the top to the bottom of the screen. And when it goes off the bottom, we want it to reposition itself back up to the top somewhere so it can fall again. We will be dealing with all the collisions and bullets and things in a later video. Today we're just going to get our object falling and moving as it should. So back over here into Unity. First thing we need is an object that's going to fall. So I need to find one of my sprites. So here's my sprite sheet that I imported. I'm going to use this green circle here right now to be my falling object. All this is kind of placeholder graphics at the moment because we are going to be retheming this into your own theme, whatever you want to make this game about and make these pieces into. So I'm going to just drag and drop this up into the hierarchy, which will drop it right up here into the center of my screen. Get that so that we can see it all at the same time. Okay, so here is my object. Let's go ahead and give it a name. So we'll just call this our falling object. And our object here is going to need a script that's going to control what it does. So we are going to make ourselves a new C# script. Let's call this the falling object script. And open that up into MonoDevelop. Here's our empty falling object script. Okay, so let's think this through. What we want our falling object to do is we want it to start up here off the top of the screen where we can't see it. And then we want it to fall just straight down the screen at a steady rate of movement until it gets down off the bottom. At which point we want it to reposition itself back up here to the top where we can't see it and then fall again. So we just want this to do a sort of screen wrapping here where it goes off the bottom and comes in from the top. That way we can reuse these objects over and over and over again, and we're not constantly creating and destroying objects, which isn't as efficient use of our memory and our processing power as just reusing objects is. So first thing we're going to have to do is figure out how can we get this object just to move straight down the screen. That's step one. So if you remember from we did our player movement, we used a command called transform.Translate. So in our player script here, we use this command right here. We use transform.Translate, which will move the transform of our object over time. We moved it along a vector 3 right, which gave a positive amount of movement to the right on the x-axis. And of course we were controlling it with our input and such. So we're not doing any kind of keyboard controls for this. This object's just going to move all on its own. But what we're going to need is our transform.Translate command to do this. So we're going to go here and in our update function, because we want this to move every frame a little bit over time so that we get the illusion of smooth movement, we're going to do our transform.Translate. So let's put a little comment here. We're going to move the object down the screen, and we're going to use transform.Translate, and transform.Translate needs a vector 3 translation. So how much to move on the XYZ axis? We want him to move down. So I'm going to say vector 3 dot down. Vector 3 dot down is a vector that has a 0 for the x, a -1 for the y, and a 0 for the z. So I could write that all out. I can make a new vector 3 and put in all the pieces, but we're not going to worry about that right now. We're just going to use the shorthand. So again, I can put a note here on this. Vector 3 dot down equals a vector that has a 0, comma, -1, comma, 0. And remember, vector 3's hold a x, y, z amount. In this case, it's the amount of translation. So I'm basically saying move 1 unit down the screen every time that you do your translation here. So let's save this and see what this does out in our project. Alright, I'm going to hit play, and actually before we do that, we have to attach the script to our object. Right now the object does not have the script, so we're going to grab the script here from our project panel, drag and drop it over. Now we have our script attached, and when I hit play, the object zips down the screen. Alright, now he's moving really fast, and if you watch the video on player movement, you already probably should have an idea of why that is. And the reason for that is right now I'm moving 1 unit down on the y-axis every frame. Remember, update runs every frame, so every frame I'm moving a whole entire unit down. Now, not only is that bad because frame rate isn't consistent, you're not going to have consistent performance between machines, but it just doesn't give us much control over the object. So let's do what we did last time, which was take this times our time dot delta time, which time dot delta time again is the amount of time that has passed between frames, so how long it takes to draw those. So it's going to be a very small fraction of a second, and that's going to cause our motion to be chopped up over a whole second worth of time. So now we're going to be moving down 1 unit per second. So if we run this now, you're going to see that our guy is moving here. Our falling object is falling, but he's moving very slow because he's only moving 1 unit per second now. So just as we did with our player, we're going to have to factor in some speed. So we're going to need a speed variable over here. So let's make a public int variable here, and we'll call this speed. Alright, and we'll put a little comment on this. Speed is how many units per second we move. Okay, that's in units per second. So now what I can do is I can either set my speed here in the start function, or I can do it out in the inspector. Let's actually do that out in the inspector, but first we have to come down in here and we have to factor in our speed. So we're going to take it, the vector 3 down, we're going to chop it up over time, and we're going to then multiply that by our speed, which will give us control of how fast we're moving in units per second. So let's go back out here into Unity and wait for it to update. And now I see my speed variable, so let's try 10 and hit play and see what we get. So here's 10. Alright, so that's not too bad. If I pull him back up here, he'll fall again. Alright, let's maybe try a 20. He should move twice as fast. That's pretty fast. See if I can catch him and drop him again. That's pretty fast. So maybe we'll stick at a 15 for now. Alright, so I think a 15 is probably pretty good. And we can change this at any time if we need to. Alright, so now we have the object moving straight down the screen. The next thing we wanted to do was when the object got down here off the bottom where we can't see it anymore, we actually want to make it move back to the top. So to the bottom, to the top. So if you remember from our player object where we did the screen wrapping, we're going to do a similar thing here for our object. We're going to be checking for the bottom of the screen, so as soon as we get off the bottom where we can't be seen anymore, then we want to just go ahead and give ourselves a new y coordinate, which will be up at the top. So let's see where that number is on our screen. So if I go down here off the bottom a little bit, let's give it a little bit of space to fall a little further. So let's say about maybe -17. That gives us a little bit of space. We're off the screen a little ways here. See, we'll be down here. Here's the bottom of my screen, that line. So somewhere around a -17 would be a good place to trigger that happening. So when the y coordinate of our object gets to a -17 or greater, let's pop them up to the top of the screen, and let's put them up here at +17 or so, so that we make sure he's off the top of the screen and he's ready to fall back down again. Alright, so in our script, after we move the object let's check to see if it has reached the bottom of the screen. So that's going to be our conditional statement, an if statement. So we're going to say if the transform dot position on the y-axis, if that is less than a negative 17, I think we said. It was either 16 or 17. We'll do 17 for now. So if that's less than a negative 17, all right, then we want to move the position up to a positive 17. So then we're going to have to say transform dot position is going to be equal to a new vector 3. Remember, we have to build a new coordinate here for it. And what we want it to do on the x, we want it to stay the same spot it is on the x right now. So to do that, we just say transform position dot x. That will go out and read the current x value of my object here. We'll feed that back in. We want y to go up to the positive 17, so we'll put a 17 there. And then the z is always going to be 0 in our 2D game, so we'll do that. So that will build a new vector 3 position to move my object to, and we will set it up to the top of the screen. So let's save this, and actually let's put a little note right here over this one. Move the object back to the top of the screen. That's what that next line does there. So let's save this and see what happens now. So here we go. He's going down, and oh, he immediately jumped to the top, and he's staying there, which means that I probably put a greater than symbol instead of a less than symbol here. Yep, look at that. I said if y was greater than a negative 17, move it to the top. Well, what I meant to say was y less than a negative 17, because it's always going to be greater than a negative 17 if it's on the screen. So that was a bit of a error there. Let's go back in here and try that again. So now he falls. When he hits the bottom, he jumps back up to the top. See what's happening here in the scene view? You can see he hits the bottom. He immediately teleports back to the top. All right, so we have him now looping back to the top. Now, if I was to play my game here, you know, I can move back and forth. If I'm trying to get under him to shoot him, this could get pretty boring because I know where he's always going to come back out from. So now that I have him looping around, let's put a little randomness in here. Let's have our falling object actually not always pick the same spot to come back. Let's have him pick a different spot side to side on the x-axis here to pop back into. Make things a little more interesting here. So we're going to add another piece to this. So not only are we going to move him back to the top, but now let's give and let's combine these things together here in our one position, a new vector 3 here. So let's change things up a little bit here. So we're not only going to move object back to the top of the screen, but we're going to also give a new random x coordinate. All right. So I think to make this a little less long of a line of code, we're going to make a few changes here. Let's make ourselves a vector 3 variable called new position. Let's call it new POS. And let's set that equal to a new vector 3. So we're building a brand new vector 3 here. And then that vector 3, we already know what we want it to be on the y, 17, and the z, 0. But now we want to change this right here. We don't want it to be the same x that it currently is. We want to give it a new x. And we want to do this randomly. So what we're going to do is we are going to get a new random number. So let's actually do that in its own variable. So let's get a float, and let's call this random number. Okay, and we're going to set that equal to a number that is a random float number. So to do that, we use a command called random, with a capital R, dot range. What random dot range allows us to do is pick a minimum value and a maximum value. Okay, now you notice down here the minimum is inclusive and the maximum is inclusive, which means that the number I pick at the bottom and the top will also be included in the choices that it can pick from. So that's, you need to make sure you pay attention to things inclusive or exclusive. So I need to know what my minimum and my maximum x values are that I want it to choose between. So let's go out here and let's see what that is. So if I move my object to the left, I don't want him to partially be off the screen or all the way off the screen. I want to make sure he's all the way on the screen, and I want him to be able to go maybe as far as almost touching the edge of the screen like this. So that looks like about maybe a negative 19. So let's just keep it between a negative 19, and then since this is symmetrical, it should be a positive 19 on this side. So the numbers I want are between negative 19 and positive 19. I want the computer to pick a random number in between there and give that to the x value of my position. So I want it to be between a negative 19 and a positive 19. And we're going to go ahead and put the f there so that make sure we know that that's going to be a float, because it needs a float here and we want it to return a float. Alright, so this will now go out and the computer will randomly generate a number in between negative 19 and positive 19, and we'll store that in my random number float variable. Alright, then my new position here, my vector 3, the x position now is going to be my random number, whatever that is. Okay, I know the y was going to be my positive 17, and my z is going to be 0. Okay, so I just replace this with the random number, and that's what I changed. Okay, so now I've generated my new position, and now my transform.Position, I'm just going to set that equal to my new position. Okay, because I stored this vector 3 right here into new position, so I'm just going to set this equal to that. I could have combined all these 3 lines into one big long line of code, but this breaks it up a little bit here. So maybe we should comment this a little bit. So the first thing we did was we generated a random number. Okay, that's what that did. And then we made a new vector 3 to store the new position we want the object to move to. And then here we moved the object to its new position. Okay, so that's broken down. So at this point, new position is going to be whatever that random x was, 17 on the y, 0 on the z. So if I save this and go back over into Unity and play it, when it hits the bottom, we should have him pick a new x. So you see now he's dropping over there, so he's bouncing around. Okay, every time he comes down and goes back to the top, he's picking a new position. Sometimes it's really close to where it was, other times it's way across the screen. So that is working well. So now we have some randomness in our game. Now there's a couple other things that we will do here. So we got to make this so we can actually see it. There we go. It would be good also not only to have it come down at a random speed here, or a random position, but what if we made some of these objects move faster than others? Instead of it being predictable and they all fall at the same rate, we could set a random fall rate for it, a random speed. Right now speed is always 15. So why don't we go in and see if we can make it fall at random speed rate. So we've got our speed variable here. We're assigning it 15 when it first starts. Okay, but maybe instead of assigning 15 out in the inspector, we should have the computer pick a random speed for it. So at the beginning of the game, all these objects will fall at a different rate, because we are going to have multiple copies of this object in our game, and we want them to act differently from each other. So let's go in our start function here, and let's set our speed equal to, and we can use that command we just learned, random.range. And then what we want to do is pick a speed between a minimum speed and a maximum speed. So this is going to be some trial and error. Right now we're moving at a 15, so let's maybe pick a 10 and a 20. So between 10 and 20, let's see what that gives us. Alright, and this is an integer variable, so it's just going to pick the number, and it's going to, I didn't put the f after here because I think it'll generate me an integer this way. If not, if it generates me a float, then the integer will just chop off whatever's to the right of the decimal point. So now we're going to have a random speed when it starts. We're also going to want to do the same thing every time we move it back to the top. So I'm going to copy this line, and I'm going to paste it right down here. So then we can say give the object a new random speed. Okay, so now not only are we moving it to the top and giving it a new random x, but we're going to give it a new random speed. So we're actually getting quite a few things that are happening here in this if statement in our update. So we're probably going to end up moving all this into a function here in a little while, just to make life a little easier, because we're going to probably need to do this in other cases besides going off the top of the screen. But for now we'll leave it here. So let's see if we get a new random speed each time when we do this now. So first thing I'm going to do is I'm going to go in here and I'm going to reset my script, because I have a hard number 15 in here and I don't want that to override what's happening in the computer. So I'm going to reset that. That just goes back into the script, that it compares what I have here to the script, and it puts it back to the script's variables. And when I hit play here, you see it picked an 18, and now it picked a 17, and now it's a 14. So we can see that it's changing. Okay, we've gotten a 16, so it's bouncing around in there. Now there's an 11. So we can get a feel for how fast things are going. Okay, and I think for now that's a pretty good distribution of speeds there. The 10 at the minimum I just saw right there, that's pretty slow. And then if we get close to the 20, that's pretty fast. There's a 19, so that was pretty quick. So we have now some random speeds happening as this comes in and moves towards the bottom. All right. So we've gotten quite a bit done already on our little object here. He's moving around, he's falling, he's repositioning himself to the top, and he's picking a new random speed. So I think that's probably enough for this video on our object falling. We have the basic mechanics and behaviors planned in for him. So the next thing to tackle will probably be collisions between the player and the falling object. So we'll have to start getting into all the things that have to happen for collisions to occur in our game, for the program knows when one thing has touched another. Alright, so I hope this video was helpful. If you have any questions, please let me know. I'd be happy to answer them.